Another way we're going to describe data sets and their graphical representations is the variation of the data. So if there's low variation, all the data values seem to be bunched around the middle. They're really close. If there's high variation, then it's going to be spread out greater from the middle. Okay, so variation basically describes how widely data is spread out from the center of the data set. Now we have two different measurements that we use for measuring the spread of the data. One is we've already talked about, which is the IQR, the interquartile range. And then we have a new one for today, standard deviation. So just like we have two measures for center that we've been using, mean and median as our two main measures of center, we're going to have two measures for the spread of the data, which is going to be the IQR and standard deviation. And interestingly enough, is IQR uses the middle is the median, right? So our spread from the median, and standard deviation we're going to see actually uses the mean as the center. And it's going to be the spread from the middle, which is the mean. Let's start with what we know, the IQR, the interquartile range. So again, that's the spread of the data for the middle 50% of the values, the middle 50. So we know we have our lower quartile Q1, our upper quartiles Q3, our median we say is Q2. So in this example, our IQR is 70.5 minus 52.5. So our IQR is 20. Now I also put the range in there. The range for the data set is for all the data values, right? So the range in this example is 80 minus 43, which is 37. So you may think to yourself, well, that makes sense. That's for the 100% versus for just half percent. Big deal. And you're right in this example. But let's say our student A was actually a 2. They got 2. Well, if they had 2, then our range would have been 80 minus 2, which is 78. So you think that's a pretty big spread, 78 versus if you looked at the IQR where our spread's only 20, right, for the middle 50%. It's really not as spread out. So we're going to see that the IQR is a very good measure for spread when we have data that is skewed. So where you have just a few values spread out at the lower end or a few real high values spread out, or it's skewed left or skewed right, the IQR is a good way to measure the spread because those skewed values are not in that middle 50%. A lot of those skewed values are not there. Or if there's any outliers that we talked about yesterday, outliers would not be in that middle 50%. So they will not affect the IQR. So now standard deviation, it summarizes the amount that each value within the data set varies from the mean. So this value tells us how tightly those values bunch around the mean. The smaller that number equates to a tighter spread for the data set. The larger the number, the more spread out the data values go. So here's the fancy formula for it. You get this little sigma, Greek symbol, sigma equals the square root of this sigma here is the summation of you're taking the difference between the value in the data set and the x bar, which is the mean value. What's the difference? And then you're squaring that. And then you're dividing that by the number of values in the data set and taking the square root of it. So that's a fancy formula. For this purpose of this class, I'm not going to make you calculate standard deviation and determine what the standard deviation is for a data set. But what I want you to know is this works best with symmetrical data. So when our data is symmetrical, what we have is this bell curve here. And within one standard deviation from the mean, that means the mean plus one standard deviation value and the mean minus one standard deviation, the number of data values in there is going to represent about 68% of the data values will be from that one standard deviation. If you go 2 standard deviations, right, we're going to find that in a symmetrical data set about 95%. 95% of the data is within 2 standard deviations. And if you go out as far as 3 standard deviations, you get pretty darn close to 100%. It's like 99.7% of the data values will be within that range. So let's take a look at what that means. Let's say for a data set, 25 is our mean. So the average is 25, and they said the standard deviation is 3. Well, if we want to go 1 standard deviation out from that, you're going to go 25 minus 3, which is 22, and 25 plus 3, which is 28. So that means the data from 22 to 28 represents 68% of the values in that data set. So it's not that spread out, right? It's pretty tight. If I want to go out 2 standard deviation values, well, then you're going to go 25 minus 2 times 3. So 25 minus 6 is 19. And you can go 25 plus 2 times the standard deviation of 3, which is 6. 25 plus 6 is 31. So that means the data values from 19 to 31 represents 95% of the values in that data set. Again, if it's symmetrical data. If it's not symmetrical data, then those percentages are going to be different. This only works when we have symmetrical data. So standard deviation is going to be our best measure of variance when we have symmetrical data. Let's talk about the best measure for the center of data. So we know mean and median are going to be the 2 main statistics that we use for measuring the center of the data set. So when the data is skewed right or skewed left, where skewed right means you have a few real large values, skewed left, maybe you have a few real small values. The median is the best measure, the best statistic to use for the measure center. Why? Because the mean is going to be greatly impacted by that 1 or 2 real large values in the data set, or conversely, the 1 or 2 real small values in the data set. So let's look at an example. So look at what happens to measure center if we look at recent home sales here in Roseville. If we look at the last 6 homes sold, right? 270, 355, 423, 460, 520,000, and 1.8 million. All right. The average, the mean home price is 638,000, right? How do we get that? We added up those 6 values and divided by 6. While the median home price is only 441,500. Well, this gives home buyers a different perception of the housing market. And this is really the reason why the median priced home is typically what is referenced when we talk about real estate for a specific marketplace. Because the median was the average between the 423 and the 460, right? Those are the middle values. So that's how we got the 441,500. Well, that's a big difference. If I'm looking to buy a home in an area, if you tell me that the average, the middle home price is 441 versus the middle being 638, it's a big difference in how much house I think I can buy. So why was the mean so much higher? This 1.8 million, it pulled the center up. It pulled it to the right. Okay. So that's why median is the better measure when we have data that is skewed. I'll give you another example. Now, I'm not going to put a slide for it, but I'll give you another example. When I look at test scores in a class, I often look at the median score is more important to me than the mean. Because what happens in a class, a typical class in high school, is you have most of your scores fall in a certain range, but then you'll have a few outliers. And I'll have a couple students that got it 10% or 15%, 12%. Well, what do those do to my mean? They lower it. They get put in the calculations, get averaged out, right? And those real low scores, they take that center of my data set and they bring it down. Versus when I use the median, those super low scores do not affect the median, right? It's the middle score. What's the middle student in the class score on that assessment? So I like to look at the median when I'm looking at your test scores because of that reason. It's not affected by a real low score. Or it could be the other way. I could have a couple students, have a class where I had 6 students that just ace it. Every time they take a test, they ace it. They get 100. And most classes aren't getting 6 kids that get 100 every time. Well, they're bringing my means getting way up. So it'd be a lot higher. because of those 6 are pulling the scores up. All right, so best measure for the spread of the data. So we kind of already talked about it, but I want to summarize it here. So interquartile range is going to be best when the data is skewed. And so with our home example here, if I looked at standard deviation here and I looked at the IQR, look at the difference. The standard deviation is 575,000 is the standard deviation. One standard deviation, 575,000. Well, from the mean, plus 575,000, from the mean, minus 575,000, that is a huge, huge spread and cost of the homes. Versus when I look at the IQR, it's saying 165,000. Well, that means the middle 50% of the homes are within $165,000. Now we're talking, right? That's not that big of a spread for the middle 50%. Gives me a completely different picture of the marketplace. Okay, and again, the IQR that's why we want to use the IQR when the data is skewed and not the standard deviation. And then the best measure for spread when the data is, I said date there, should be data. See if I can fix that. Data is going to be standard deviation is when it's symmetric. So symmetrical data, we'll go ahead and use the standard deviation.